Welcome to Independent Truths with Scott Atlas, brought to you by the Independent Institute, my show that brings a uniquely rational perspective to some of society's most complicated issues. Today's guest is Professor Steve Koonin of New York University. His best-selling book is called Unsettled: What Climate Science Tells Us, What It Doesn't, and Why It Matters. He served as Undersecretary for Science in the Department of Energy from 2009 to 2011, and that before that was Chief Scientist for British Petroleum, and for almost 30 years a professor at Caltech, where he served as Vice President and Provost. He's the recipient of numerous honors and awards and is a member of the most senior professional society, including the U.S. National Academy of Sciences. He has a bachelor's in science from Caltech, PhD in theoretical physics from MIT, and we have a fascinating conversation about climate science, the narrative about climate change, and in a broader sense, how that relates to the state of science in general as it has become more visible in the media and public policy. Thank you for joining us, and stay tuned. Okay, welcome, Professor Steve Koonin. Thank you for joining us today.
Happy to be with you, Scott.
I'd like to dive right in and talk about what might be the most contentious issue of all today, which is climate change. And I was impressed by hearing your presentation at a recent event. You started off by the statement about climate emergency, and I'd like you to just ask or respond to this. Is there a climate emergency today?
No, of course not. And, the official science as put forward by the IPCC or there in the research literature provides scant support for the notion that we're facing an emergency. We've not broken the climate according to the behavior of the weather over the last 50 years, nor do the models project catastrophe. It's entirely a political construct.
Yeah, and this is sort of really quite frightening because it's certainly in the popular press and in day-to-day life constantly said that there's a climate emergency. And I think it goes to why that's said and on the basis of what. Because something that I've been struck with is all of a sudden we're talking about broad statements and conclusions about data based on what you might call single event data. What is your impression, and is this one of the biggest issues that we're facing today?
Well, it's an issue, but there are certainly far bigger ones: poverty, some of the geopolitical situations we've got right now. Those are far more immediate, tangible, and soluble, frankly, than the notion that we face some climate emergency. You might ask, why are we talking about that? And I like to say that it is a alignment of interests of several different factions. The media, obviously, they like drama. They like leading headlines, if you like. The politicians, I like to quote H.L. Mencken, who said, "The purpose of practical politics is to keep the public alarmed so that they can be clamoring to be led to safety." And then there are the scientists who seek prominence, funding, by proclaiming that there is an emergency. And by the way, most working-level climate scientists are pretty sensible when you talk to them in private. It's the few that have a public profile that have been talking about emergency, crisis, and so on.
And I think we've seen, given all that, it's also true in my perception anyway, that science is more visible. It's used as the sort of measure of public policy more today than in the past. I think it maybe began many years ago with population, so-called science, but certainly the pandemic and the management has thrust science and so-called data into regular conversation. And this is good if it was legitimate data.
Yeah, there are legitimate climate data you can find on the web from the U.S. agencies, from European, Japanese, good data about temperatures, precipitation, ice loss, sea level, and so on. The problem is nobody ever looks at the data except the scientists. And when I teach my students, as I am doing currently, it is believe nothing from the media. Go check the data and the papers yourself.
So that's exactly what I think, and this is the new burden on the public, really, not just students. Of course, we speak to the public, and the public relies on credible people, which is appropriate. But the idea of assessing someone's credibility just on the basis of their background seems to have a lot of pitfalls. So there's a new burden on the public to sort of look like what you're saying. You have to go and examine some of this data.
Yeah, and it's not hard. And those of us who talk to the public, as you have in other spheres, I'd like to just show the data. If it's a simple graph with citations and a link or source, people can go check for themselves and then go ask the other folks who might have a different picture, how come I haven't heard about X, Y, or Z?
Right. So let's talk about what the climate data does tell us and what it doesn't. And maybe, I know we don't have, there's a lot in that question, but maybe you could make it succinct for the audience.
Yeah. So, the first is the factual statement that the average temperature of the Earth has been going up over the last 140 years or so. It's gone up, let's say 1.1 or 1.2 degrees Celsius. And I'll talk in Celsius rather than Fahrenheit. Assuming your audience can convert. It's just a factor of 2, effectively. So the Earth has been warming by about 1.1 degrees over the last 140 years. We also know that warming has not been steady. It warmed pretty rapidly from 1910 to 1940, and then actually cooled a bit from 1940 to 1970, and then has been going up since about 1980. We know that human influences on the climate, predominantly the accumulation of carbon dioxide in the atmosphere from the burning of fossil fuels, exert a warming influence on the planet. And that warming influence has been growing. If you go back 90 years, it was only 1/5 of what it is today. And it has been growing steadily. It's still small physically. It's a 1% influence on the climate, but it has been growing. You might ask, beyond the rising temperatures, what else have we seen change? We've seen an increased incidence in heat waves, although not in the U.S., and that's an interesting story why. We've seen temperatures on average going up. But beyond that, it's really hard to detect changes that you can attribute to human influences because the human influences are small, the record is not great, and the climate is noisy. There's lots of variability due to other factors, including just natural variability. So when you look at what the UN says, no long-term trends in hurricanes with a small asterisk. Sea level rise is not anomalous relative to what it was doing long-term. Snow, ice, melting of Greenland, and so on. Yes, there are fluctuations, but if you take a longer-term perspective, namely multiple decades, as we need to do for climate, the UN says we can't detect a trend, let alone attribute it to human influences.
And so if we make the conclusions that you've just outlined from that, what about what is obviously the implication for what the proposals are of changing human behavior to address these things that are, seems like most of these things are really not really legitimate issues?
Well, there's probably some small risk at the 10 to the minus whatever level, to the minus 3, 10 to the minus 4. And the question is, do you want to try to mitigate that risk by dramatically changing the way society does its business, by changing the energy system? Or is there so much cost associated with that, so much disruption, and frankly, other reasons why you might not want to change the energy system? You know what? I often use the analogy, you can tell me whether it's good or not, with the COVID situation. You could have locked everybody down, and we did. And maybe that had some positive effect, but you had to weigh that against the negative effect that the lockdowns had in terms of economy, development of kids, and so on. And that's the kind of balance we need to strike in deciding what to do about the climate.
I mean, speaking of the balance, that you just articulated, the recent meeting in Dubai, there was a statement made by, I think, the person who's the president of the meeting that was played up in the UK press. I didn't see much of it in the US press, interestingly, where he said that he really said it's completely inappropriate to stop the use of fossil fuels. Maybe I'd like you to articulate that a little better than I just did.
Yeah, look, there are a lot of reasons why you don't want to do that. One is that there are 6.5 billion people in the world, outside of those of us who are fortunate enough to be in the developed world, 6.5 billion people who don't have enough energy. The numbers are astounding. For example, somebody in Nigeria uses 1/30th the energy that one of us in the U.S. does. And there are 3 billion people who use less electricity every year than the average U.S. refrigerator. And so those people need energy. They're going to need a lot of it. It's probably going to double a 50% increase in the global energy demand over the next 30 years. And the best way for them to get that energy is with fossil fuels. And as people have pointed out, particularly Alex Epstein, it's immoral for us to say you can't use fossil fuels. So that's one. The second reason is you can't change the energy system overnight. It takes decades to change existing energy systems. We see that in the way the U.S. energy system has evolved. It takes a long time because the facilities last a long time. A coal plant might last 50 years. Automobiles last 15 or 20 years. And you don't want to make changes too rapidly because we need the system to be very reliable. And the reliability, for example, for the grid is 99.99% or something like that. And so slowly, if you're going to change things.
Right. I'd like to interrupt here and make just an observation, which is that it seems to me in common sense doesn't make sense what we're doing, which is somehow to abruptly dissuade or even prevent or stop the use of conventional, energy and gas and oil without being ready to have the substitute available. That's sort of what you're saying. You would think the appropriate way to do this is to make sure that we have all these alternative energy sources ready to go before we turn off the switch on the other ones.
Right. For whatever problems there might be, and we might have with China, Mr. Xi said almost exactly what you just said a couple of months ago. Namely, we're not going to abandon our existing energy system until we've got something that is an appropriate replacement. And that means economically, it's got to work. It's got to work in terms of reliability, and it's got to work in terms of scale, namely that it can take over an appropriate fraction of the system.
So, Steve, let me ask this. The support for electric vehicles, for wind and other alternative energy sources, is this a realistic point of view that there is going to be sufficient energy supply to live the modern life that we lead or not? I mean, it seems, what's your view on that?
So let me talk about the wind and solar thing, which is relatively at the heart of all of this. Wind and solar are, in fact, the cheapest ways of generating electricity right now. Cheaper than gas, coal. And that you'd say, that's wonderful, let's just build a lot of that. And the problem is that they're intermittent. The wind turbines turn only when the wind blows, and the solar panels produce only when the sun shines. There are, of course, short periods where the sun doesn't shine every night, for example. You can fix that with batteries. The wind variable, it goes out for a day, fine. We can fix that with some batteries. But every place that people try to put wind and solar in, whether it's in Germany or in the UK or in Texas or California, there are long periods where the wind doesn't blow and the sun doesn't shine, long in the sense of weeks. The Germans have a word for this. This is called Dunkelflaute, which means dark stillness. And so you need a backup system, and that's at least as capable as the wind and solar. And that backup system is going to be more expensive than the wind and solar, so you wind up running two parallel systems. And you then might ask, why do I need the wind and solar at all? And I would say that's a very good question. So I like to say wind and solar can be an ornament on top of a backbone of a reliable system, but they can never be the foundation of the system. And it will raise the cost by a factor of 2 at least.
And where is the role of nuclear here in this discussion? We see some other countries, notably France, I think, is one of the classic examples of really being very forward-thinking on nuclear power, whereas we're doing sort of the opposite, it seems, in the United States.
Most people who have seriously studied this have seen two things. First of all of the troubles that we're seeing now with the energy transition could have been, and in fact were, foreseen by people who knew 20 or 30 years ago. So that's one. The other thing that people agree on studying this is nuclear has got to be a big part of a carbon-free energy system. The reason is it is reliable. It is relatively low cost. It's established. And it's emissions-free. So it is the backup, if you like, for the wind and solar. And, any technical person who's looked at the numbers and understands the energy system comes to that assessment. And slowly, the political and popular world is realizing that. But the U.S. And a number of other countries have been asleep after a flurry of building plants in the 70s and early 80s.
Is there any kind of momentum at all in our policy world, in people in power, to start opening up nuclear as an option?
So the EU has recently said nuclear power is okay. Germany was not happy about that, but France was, and the UK is moving to that. In the US, we're slowly starting that up again. When I was in the Department of Energy, I helped get small modular reactors under development. One of them, unfortunately, just got canceled, a small one, because the cost spiraled out of the range where they were willing to tolerate it.
Not canceled in the social media sense.
No. Sorry.
Right.
I'm engineering or programmatic sense.
Yeah.
It may have been canceled in the social media too. Who knows about that? I suspect it was. But, we will eventually learn how to build small nuclear reactors, and I think they will be a backbone of the energy system.
You made a comment that wind and solar will essentially never be the foundation of energy. What about the idea that not in the short term, but technology, of course, evolves very rapidly? I don't have to tell you that. You know way more about this than I do. Is there optimism in people like you and others who think that, okay, technology is advancing so rapidly that one day this isn't a pipe dream, that wind and solar and everybody drives an EV? Or realistically, no, that's just simply foolish.
No, and let's distinguish the EV discussion, which we can talk about in a minute, from the wind and solar generating electricity.
Okay.
The panels might get more efficient. The turbines, it's hard to imagine them getting more efficient. And, when the wind doesn't blow, it doesn't matter if you put in twice or three times as many turbines. 3 times 0 is 0.
Right.
So it doesn't help.
Okay. Let's talk about electric vehicles and eliminating the use of gasoline and even natural gas.
Right. So electric vehicles, I think, we've gone too fast in trying to go to full electrification, namely battery electric vehicles. The batteries are not quite cheap enough yet. They're not light enough. Batteries are heavy. And there are better alternatives right now. I mean, I don't own an electric vehicle, and I wouldn't buy one for two reasons. I mean, quite apart from the range issues. One is the safety issues. The batteries carry a lot of energy and can suddenly catch fire, so I worry about that. And then the second is an economic issue. The batteries wear out after 10 years. The battery is half the value of the car in contrast to an ordinary engine, which is 1/5 or less than the value of the car. And so the resale values are not great at all. So
hasn't the battery technology been the limitation forever, really, with this? I mean,
it is. It is.
Therefore, the question is there a lot of optimism and new things happening in battery technology, or is that just sort of a very slow advancement?
There always, you can never say there will never be a breakthrough. But, when you charge and discharge a battery, there's kind of molecular mayhem at the molecular level as the ions go in and out of the electrodes. And so it's hard to get the lifetime up. The other problem is that you can only charge a battery at a reasonable power level. I mean, your ordinary appliances in your house run at a kilowatt. Ideally, you'd like to charge at 100 kilowatts, which is a lot of electrical power. But even at 100 kilowatts, 100 kilowatt hours of range, which is about what a full-size EV takes these days, takes an hour to charge. And so I can't charge at that level in my house. And if I go to a charging station, I'm going to have a long cup of coffee while I wait to get to the front of the queue and then get charged up. So, when you fill up your tank with gasoline, you're wielding 10 megawatts of power compared to the 100 kilowatts, so a factor of 100 more power in the gasoline pump than in the electrical charging.
And what's the risk to the power grid itself? If everybody, is there a risk, or is that not a big concern?
Yeah, so we can easily generate the energy that we need. It's not a big hit on the electrical energy, but it is a big hit on the electrical power because everybody likes to plug in at the same time when they come home. So we're going to have to learn how to space that out. And so the stress is more on the distribution system. If you've got a transformer near a cluster of homes and everybody plugs in at once, we're going to have a problem. There are sensible paths to electrification that somehow the U.S. has decided to leapfrog. So a plug-in hybrid, which runs for a limited range on batteries and then switches to a gasoline-powered engine, is a wonderful solution because most people don't take long trips most of the time. If you have a 40-mile electric range, you'll never use any gasoline until you decide to go a couple hundred miles.
Why has that been sort of ignored by in the United States?
Yeah, well, you can buy them. Toyota is pushing them not only in the U.S. but more abroad. But, energy has this ideology fanaticism about it for most people that refuse to look at it with a serious cost-benefit analysis. That's another general problem, if I can move off the consumer for a minute. People who understand the energy system and are deeply technical, so the people who run utilities, for example, the oil folks, the gas folks, they are shut out of the regulatory process. In California, the Public Utility Commission has nobody, well, maybe one person, I don't know, who really understands energy, both the technical and the business aspects. And so what you get instead is a bunch of ill-informed amateurs who are driven by ideology trying to set energy policy.
It sounds
And
familiar.
that's a recipe for disaster.
This is a common theme, I think, that has either become something that we didn't see before, or we just weren't aware of the lack of actual knowledge in the people who are making the policy. I think, I saw it, I was shocked about COVID, and this is the same kind of thing with climate. I think there's a significant commonality in the discussion. Why is climate so politicized, or is it just politicized like everything else in your view? And this is sort of taking a step back, and is it just climate that is politicized this much, or is basically everything now?
Everything is politicized, but, climate is something, and when you say climate, I assume you mean climate energy.
And energy policy, yeah.
I mean, I like to say energy touches everything, everywhere, all the time. And it's the lifeblood of society. And so you can have, incorrect or false beliefs about it. And that's going to do great damage if they come to fruition. Climate is also something that I think touches everybody personally. Probably pandemics are up there as well. And the politicians have latched on to it in, I think, inappropriate ways.
Yes. So the final topic is, how do we return science to showing good data? Your book is all about what the data shows, but what it really doesn't show. And how do we use it? Because now that we know science and data is so front and center in the public discussion, which I think this is new, sort of a new era. Therefore, it's very influential to the public and public policy, but we need to be a society that understands that science is important, but there's bad science and good science. I mean, how do we fix that?
Boy, that's really hard. Climate, not so much energy, but climate is distinguished among the sciences in having an official narrative put out by the UN's panel every 6 or 7 years. And I have long advocated for a red team review of those assessments. We almost got to do one during the Trump administration, unfortunately. They decided not to go through with it. But I think a good hard scrub, in the sense that an academic referee would go through a research paper.
Exactly.
Would let us get much better assessment reports. That's one. I think the professional societies, and here I look at the National Academy of Sciences, but also the disciplinary societies, have fallen down by not calling out the politicians and the NGOs and the media when they misrepresent things. So we need to do that.
Exactly, what we saw in the pandemic management. It's so parallel. I think. Go ahead.
No, I'm just saying, during the pandemic, you were under time pressure, though. I mean, there really was an emergency in the sense people were dying. You had to decide what to do.
Right.
The climate unfolds over years, if not decades, and so there's much more time to either spin an improper narrative or to try to correct what's going on.
Are there efforts, to your knowledge, going on? I mean, you're somebody who's worked in different administrations. Are there efforts talking about reviewing the data from the UN and the science data, or is it sort of, we're finished and now we're just going to act as if we know?
Yeah, I think it is the latter. The scientists who put together these reports do not want to engage. There have been independent, unsanctioned reviews of the assessment reports, which often turn up embarrassing misrepresentations. I wrote, the book is all about, not all about, but mostly about misrepresentations in the official science when you get to the summaries. I teach a class in climate science at the master's level, and every week students are supposed to go through the media, find a climate science story, dig into it, look at the data, look at the original research, and almost always, when you turn over that rock, you find something that you're not proud of as a scientist.
Yes, in the field. Let me ask one more thing, which is, what has been the reception of your book? I can guess, but why don't you let us know what because you're basically injecting the appropriate, not just critical thinking, but the healthy degree of skepticism that is essential to determining truth. That's my view. What is the view of the people in your field and even in your university?
So I've gotten a lot of unsolicited emails from quantitative, critically thinking people who've written and said, thanks for writing this. Thanks for showing the data. And that's great. I've gotten roasted by some people in the climate establishment. But what I find when you look at what they've written about criticisms of the book, they either misquote me or attribute things to me that I never said before. And it's terrible. All right, you probably
Sounds familiar. Yeah, exactly.
And that kind of inappropriate criticisms propagates virally and is used as a marker for people who just want to go after you. Right. On the other hand, when I talk to climate scientists privately, interviews those who are willing to talk to me, I ask them, what did I get wrong? And they say, Steve, you got it mostly right. So I'm still waiting to engage with some of my critics in a public way. I've been doing debates. I don't know if you've ever done debates about the things you write about. I think I've done 6 Oxford-style debates so far, and I've won 5 out of 6, and 1 was a tie.
Yeah.
Against credentialed people. So there's a hunger out there for a straightforward, factual portrayal. I think the fact that we've sold 200,000 copies of the book is testament to the fact that people want a straight story without emotion, data-driven, and so on.
I agree with that. In fact, I think that's why we have to keep speaking out. Like you said, there is a thirst for really understanding the facts. And I think people understand also that they have not been given the facts on a lot of issues. So we need to keep speaking. Well, yep. Steve, I'm gonna let you go. Thank you very much for spending the time today, and I hope we get to do this again and follow up.
Okay, that'll be fun. Thank you.
Thank you for listening to Independent Truths with Scott Atlas. If you want to find out more about today's guest, Professor Steve Koonin of NYU, follow the news on his efforts to educate the public about the actual data on climate change, and read his book, Unsettled: What Climate Science Tells Us, What It Doesn't, and Why It Matters. And don't forget, subscribe to this show on YouTube as well as Spotify, Apple, Google, and anywhere else you're listening to podcasts right now, and I'll see you next time.